like it, or stay at home if they feel like it. And, I think this is the way of the future. So that's probably good. The last year or so, I've been in 8 conferences around the world from my library at home. And it's nice because you have no jet lag or travel costs. But I miss the personal interaction with conferences and classes. So Stanford is not ahead of USF in any way by that same mode. We're still working out that interface. So I'm thrilled to be able to be part of that. And when it's live, I get to hand around 500,000-year-old hand tools, you see, like this. So, if you don't want to pass it on because of contact with, if you're at all feeling, anti-germs or whatever, then don't. But I will pick it up at the end. And if you want, you can come see it too. We'll leave it at the front if it makes it back. So today, we're starting our course on the great heritage of Spain, the archaeology and art of Spain. So that legacy of Iberia, named after the Iber River, Iber in Herodotus, which now we call the Ebro, but it still has left its name to Iberia, and even in modern times, like Iberian Airlines, etc. So when you think about this history, today we're going to go back maybe 1,000,000 years. Hard to say exactly, but we're going to certainly be in the Paleolithic and moving right to the Neolithic. And as you know, Paleolithic means the old Stone Age. And Neolithic then obviously means the new Stone Age with the Mesolithic, the middle Stone Age in between. We don't have a lot of Mesolithic in Spain, but we definitely have a lot of Paleolithic. And we will bring it to, roughly speaking, about 10,000 years ago today. So that's our time span today. We're not going to be in the recent past. We may get to the end of the last ice age in the Holocene, which is the period of, shall we say, from prehistory to history with humanity. There are a lot of terms I'm going to throw out, but I hope that I will not be jargonistic and I'll define those terms whenever possible. So I'd like to start off, and I can't see now the people who are on Zoom, but I'm assuming I know you're there, but I'm just curious, how many people have been to Spain? Almost unanimous, almost every one of you. That's great. So when we get to places like the Alhambra and Seville, and of course, Madrid and Segovia and all those other great places, you've already been there, and that's great. It's important. I'll be back there again in March during our Stanford spring break. And I love Spain. And I wish we could, just even do a course on Spanish food and Spanish wine, thinking again, Iberico, you see. But today, we're not going to get to Don Quixote, but eventually we might drop him around a bit. So when we look at Iberia and the name Spain, which is, of course, more modern, historic, we realize that it wasn't called Spain until the Romans named one of the provinces there, one of the 3 provinces, Hispania. And, when we think of the gamut that we'll cover, I'm sure you've seen a lot of Roman material in Spain. Certainly you've seen those great aqueducts. But the 2 greatest emperors in Roman history, Trajan and when you think of Trajan, certainly, and Hadrian, they were born and raised in a town very close to Seville called Italica. So they were Spanish Roman emperors. And that's because of the incredible mineral resources in Spain, the great Iberian Pyrite Belt, which funded a lot of Roman expansion in the silver. It certainly funded Hannibal, but that's a whole other topic. So today we're going to just begin, and I didn't want you to think that we're going to stay just on stone tools and Stone Age, because we're going to go all the way to Castile and Aragon and the Reconquista, and that we'll get literally to the 16th century. And I'm sure some of you have been in the largest Gothic cathedral in the world. Yes? The great cathedral at Seville. So today, however, we're going to be way in the past. And so I'm going to jump into the slides in a minute. But apparently, we will take a break at the midway, and you can have questions along the way. I would prefer if we have questions at the break and at the end, if that's okay. But if not, if you have a burning question that you really think everyone should also hear because they may be having the same question, because I've left something out, don't hesitate to raise your hand. But let's now think about some of the reasons why Iberia and Spain have impacted history so strongly. We're going to look a little bit of geographical terms today, a little bit of glacial history as well. So let's go there. And I'm sure you can all see this. Are the fonts clear and visible? Good. Sometimes they're not. But when you think about where Spain lies geographically as a peninsula between the Atlantic and the Mediterranean and the immediacy of Africa, you know, it's a very short distance across what were called the Pillars of Hercules, or Melkart to the Phoenicians, the Straits of Gibraltar. And that even name, the name Gibraltar, is named after a Moorish person. Now, this year, I've been very fortunate. I was in Morocco for about a month, long before the devastating earthquake. But Morocco has had an incredible influence on Hispania and Iberia and Spain too. Because when you go to the Alhambra, you're looking at mostly Moorish art from Al-Andalus. And when you go to Morocco, you see the origins of much of what makes Granada and the Alhambra so beautiful. But it's not just the Moorish influence. Humans traveled not just up the superhighway of Africa that we call the Nile River, the out of Africa expansion of hominids, but they also came across Gibraltar. And it's very likely, almost certain, in fact, that at one point, the Straits of Gibraltar were a dry isthmus because the Mediterranean used to be an evaporatic basin. In fact, those of you who've sailed across Gibraltar know, if you've gone to Tangier from Spain, you know that the water is flowing into the Mediterranean from the Atlantic. It's not the other way around. There's more water evaporating out of the Mediterranean Sea than flows in because of the climate there. The Mediterranean climate can be very hot, very evaporating. So regardless of the Black Sea, with the, you know, when you think of all the rivers, the Volga, the Don, when you think of the Dnieper, you think of the Danube, when you think of the Rhone and the Po and all the other great rivers, including the Nile, more water evaporates out than comes in. That's why water's flowing in from the Atlantic. And that little bit of sea, that little bit of marginal sea entrance between Spain and Africa, as I said, used to be a land bridge. So hominids, or humans like us even, have crossed that land bridge. So humans have been crossing from Africa from two different points, at least, maybe more, but certainly from the Nile and from what we call Gibraltar. And we'll look a little bit at that today. Now, this picture tells you something entirely different. It tells us that when we had the last ice age, roughly speaking, from about 20,000 years ago to about maybe 12,000 years ago, there was a huge ice cap. What we call the Arctic ice cap was much, much larger, and it has fluctuated because there have been, at least in the last 100,000 years, multiple ice ages coming and going. And the extent of the ice in Europe at some points has reached all the way down to the Pyrenees. maybe beyond. There's not a lot of glacial evidence in the Pyrenees for glaciers beyond, but in the last ice age, for sure, and it was in the previous ice ages when Spain or Iberia was ice-free. And that's important because when you think about human prehistory, when you've been to Lascaux or La Madeleine or Les Aziz and the Dordogne, the great French caves, or you've been to other great cave systems in Europe, you know that much of the surface action of hominids or Homo sapiens or Neanderthals or whatever else, Heidelbergensis, habilis, whatever other human or human-like primates have been in Europe, their action was scraped away from the surface. There was very little evidence left on the direct surface because those glaciers, which, as you know, are rivers of ice, they grind up and pulverize surface level or superficial material. So the only evidence we often have for those peoples, if we can use that term broadly, are what's in the caves deep below the ground. Does that make sense? Why is this really important? Because Spain, for so much of that time, was glacial free. That meant that human peoples, again broadly, could habitate Iberia and Spain, and there's plenty of surface evidence for them as well. As you know, of course, many caves, but many of the caves in Spain are not deep below the ground. They're often right at ground level, and that makes accessing them and recording them much easier. Now, with that, you can see this where the ice cap and what we call the last glacial maximum to minimum. It's hard to say exactly when it was at maximum, but some people think it was around 18,000 years ago. And you'll notice that I use the term, you can see here, KYA, K for the Greek term kilia, you know, for thousand. So KYA means thousands of years ago. So about 18,000 years ago, the last glaciers that scooped out the last bits of what we call Lac Léman, the lakes around Geneva, and some of the last great alpine glaciers that creeped out across Europe. Over Norway, 18,000 years ago, there was a glacier that was possibly a mile thick. Now, I'm usually in Norway every summer, and I spend a lot of time in the fjords. And those fjords were all carved by glaciers, and they're often as deep underwater as they were above the cliffs around them. And because they're fjords, they're connected to the saline oceans. That's one of the definitions of a fjord. It has to be connected to salt water. And those glaciers that carved out the fjords of Norway, the last ones were about the same time. Now, they've been being carved for many thousands of years, in fact, possibly hundreds of thousands of years. But what we see on the European topography today is very well marked off by glaciers. And as a geoarchaeologist, I often work on glacial evidences and the human rehabilitation of when the glaciers leave and humans come back. So that's all preamble to where we're going today. Just so you know, the main point I want to make right now is that Spain has been mostly free of glaciers throughout these ice ages. Now, here's just a sort of a scale, a graph showing what we call the latter half of the Pleistocene. So literally, you know, if you think about the last million years, you can see where we are today at the very terminus on the right-hand side. And you know, we could argue till kingdom come about global warming and climate change and recurrent cycles and human impact and what we call anthropogenic change made by humans. But let's not even go there because you don't have to politicize science. In fact, you shouldn't. But here you can see where we are. The Holocene is the last 11,000 years, and that's marking the last vanishing glacier, 11,000 years ago, about 12 to 11,000 years ago, the last ice age in Europe vanished. those big glaciers across Europe melted and left many smaller glaciers behind. But you can just see that there have been different glacial episodes. There was a big, if you look at this map, and I'm not sure if the people who are on Zoom can see this, but you can see there was a big ice age. There was 200,000 years ago. The last ice age was right here that you can see. And we are in this, that's the last ice age right there. Do you see it? Kind of oddly marked. But now, here's another view of it over Europe from a French source, showing maybe, I wouldn't say this is necessarily 18,000 years ago, but you can see glacial lines across Europe, and you can see as well glacial limits. The maximum is probably the big blue line there, and as they receded, can you see that one glacier over Norway and Sweden, 3,800 meters thick? So that's easily over a mile thick of ice. So now, if you look again at Spain, Iberia, over on the far left, you can see that while the Pyrenees and some of the Cantabrian mountains still had some small glaciers, it wasn't part of the ice age. They were separate from that. And you can just see here some of these areas that we're going to be looking at today. But we're going to be looking at areas all over Spain. Now, with that, let me just close that. With that idea, this is one of the most famous places in the world for Paleolithic art. Literally, when we think about this, Aurignacian, Magdalenian, Solutrean, these are maybe not words you remember, but we'll look at these today, some of these periods in the Paleolithic. But remember, these cave paintings were painted before the last ice age, because the last ice age didn't start until about 20,000 years ago. So these cave paintings were painted in an intermediate period, what we can call, there was not a big glacier 20,000 years ago, and there wasn't a big glacier 36,000 years ago. So these cave paintings in Altamira were between two ice ages. Can you see that? There was an ice age 40,000 years ago and one 20,000 years ago. So these cave paintings are in that intermediate glacial free period for sure. And we'll come back to this toward the end today. Now, much of the material I'm going to be showing you artifactually is stored in the Museo Arqueológico Nacional in Madrid. Have you been there? You should. If you've been to Madrid at all, this is a fantastic museum. And I was there last year. I'll be there again this year. And a lot of these artifacts are there. It's a great, great museum, a great world museum. Now, let's go back and look at the overall map. Here are the sites we're going to cover. We're going to look at all these sites that are marked in red. I'm not sure that they're completely legible, but the little yellow pentagons with a black frame are cave sites. And you'll see that we'll go all the way back to Homo heidelbergensis, marked with H, and Homo neanderthalensis, marked with N, and Homo sapiens, marked with S. And some of them share all three, but that's pretty rare to have a cave with all three of those phases of hominids. This is a selective map. This is by no means comprehensive. There are probably at least 100 sites that I don't have on this, but I tried to select the most important ones. And I think you understand, as I do, that we haven't discovered all the cave sites yet. So there must be many, many, many more, maybe as many more that we don't even know about yet. Maybe those cave sites are covered. Maybe the cave mouths have collapsed. Maybe the detritus and the erosion has covered them up from the mountains around them that may make them not visible to us today. So there's probably a lot others that we don't know about yet. Who knows what we could yet discover? But here are some of the basic terms that I'll be sharing today. So MYA means millions of years at the top. So these are generalized terms. I'm not going to be able to define them explicitly, everyone, but KYA, thousands of years. BP means before present. So anytime you have a date that's before present, it's going to be 2,000 years before our common era. We call common era essentially around the year 1 with Augustus. We used to use BC before Christ, but we use a non, we try to have this idea of non-parochial, although I still love BC and AD. In archaeology, we try to be neutral. So BP just means add 2,000 years to the present, right? So that's what we say BP. And then you'll note that the lower Paleolithic, meaning a long time ago, and in archaeology, the deeper a level, the older it is. That's a law of stratigraphy. So the same thing in the time column. The lower it is on the time column, the further it is from the present. That's what we call lower Paleolithic. Then we have middle Paleolithic, and then we have upper Paleolithic. And we are beyond that because we are now at the bottom of this time scale. So it's reverse. Isn't that interesting? This is reverse to what I'm talking about, isn't it? Because I put lower at the top and present at the bottom. But in reality, we talk about lower, meaning older, the deeper. So you'll see that today we'll mention Homo ergaster, maybe 1.4 million years ago. We don't know how much presence Homo ergaster had in Spain. The evidence is ambiguous. However, for sure, we have Homo heidelbergensis, a hominid named after the town of Heidelberg, which I love, by the way. And I was a visiting scholar there a few years ago at Heidelberg University. But Homo heidelbergensis, or what we call Homo antecessor, just meaning antecedent, early. So that's about 500,000 years ago. And that's the date of this stone tool that I'm going to pass around. Okay, but we're not there yet. We can call it sort of an Acheulean hand axe, but maybe similar. Now, we then go to the middle Paleolithic, 400,000 years ago, to only 28,000 years ago. And we were there by 28,000 years ago, Homo sapiens. So Homo neanderthalensis is middle. And then upper Paleolithic, we have Homo neanderthalensis, and then we have Homo sapiens. And you can see that we overlapped. Some people are, I think, wise to wonder if maybe we should say, instead of distinguishing between Neanderthals and Homo sapiens, maybe it's not two separate species. Maybe it's more subspecies than separate species. That's a new argument that's just being generated. Why do we ask that question? Were the Neanderthals a separate species from Homo sapiens? If they were, how is it that we mated 300 times at least and have common DNA today? We have, every one of us probably has some Neanderthal DNA in us. Did you know that? Yeah, we have, the maximum you can probably have is about 5%. And I know 2 people who have 5% Neanderthal, and one of them, who's very near and dear to me, has all the phenotypes, the genetic phenotypes as well. But she's only 5% Neanderthal. However, were they separate species? One of the rules in biology, or we call it laws, is that separate species aren't supposed to have fertile offspring, even if they mated. Technically, we can ask Tarzan about this and Edgar Rice Burroughs. You know, could gorillas mate with humans? Yes. Not likely. It wouldn't be very pleasant, I don't think, for at least one half of that, mating. But could it happen? Yes. But would there be offspring? Doesn't seem possible to have offspring between gorillas and humans. But the fact that there's 5% Neanderthal DNA shared with us today suggests that when you have fertile offspring, maybe it's not separate species. Most times in biological interactions, what do you get when you cross a horse with a donkey? Is it fertile? No, you can't have fertile offspring. So a mule, which is 2 separate species, a mule is the hybrid between a horse genus and a donkey genus. And yet we have fertile offspring evidence in our DNA between Neanderthals. So maybe it's not a completely separate species. Maybe we should say Homo sapiens sapiens and Homo sapiens neanderthalensis for those forebears. But that's an argument that we're not going to solve today. In any case, we'll look at this a little more closely. Now, Homo neanderthals are called that from the Neander Valley in Germany, where National Geographic sent me a few years ago. I think you may know that I've been working for National Geographic for about 25 years. And as a funded explorer and grantee, as well as expeditions leader, and we've made a lot of movies, a lot of documentaries. And so they sent me to the Mettmann Museum in Germany, and I'll come to that later. But here are now in what we call the Upper Paleolithic, the two species that interact, Neanderthals and Homo sapiens. And then you have these periods, the Chattel-Perronian, the Aurignacian, the Gravettian, the Solutrean, the Magdalenian, and then what we call Epi-Paleolithic, meaning on top of Paleolithic, we then have Mesolithic to Neolithic. So Mesolithic is between somewhere about 12,000 years ago to about maybe 10 or 8,000 years ago. But mostly we now say we can extend the Neolithic back about 10,000 years. So maybe the Mesolithic is shrinking. Maybe we can just say Paleolithic, Epipaleolithic, and Neolithic. Whatever. We won't argue that. However, here now, when we look at Homo sapiens, the last entry in this says Homo sapiens for sure after the last glaciers 11,000 years ago. This is now the Holocene, what we call the Holocene, Holocene. And it's often called the Anthropocene, meaning human impact on the world. So there we are. Till about 4,000 years ago is considered the end of prehistory in most places. The New Stone Age lasted beyond when the Bronze Age started elsewhere. You have still the Neolithic, the Stone Age, in the Alps and up in parts of Britain and northern UK, when the Copper Age and the Bronze Age have already started down in the Near East. So you have overlapping even then. But the last Stone Age, some people would say that some of our Paleo Americans, even 300 years ago, were still living in the Stone Age, right? Stone tools, stone axes, arrow points that are stone. Could that still be leftover Stone Age? I think we could culturally wonder about that. Now, a lot of terminology. I hope this isn't bewildering or boring, but let's now go back to Spain. So let's look at the map, and we're going to start. I've underlined some of these first caves, or I've underlined, as we go through them in sequence, I'll show them with an underline. So let's go to Atapuerca Cave, up here with both Homo heidelbergensis and Neanderthal, excuse me. There it is. You can see it. You can see it kind of on the plain up there. If you look, the central plain, and just to the eastern side up here, we have this big cave, the northern, between the central and northern plains. And you can see that we don't know yet if it had, and here's the cave sequence. You see the middle picture here shows you how the caves are spread out. And it was discovered by making a major highway, a major super highway across Spain encountered these sites. Do you see them? Here are the caves, and they don't necessarily connect, but what you see in dots, the dots is the road. You see that? It's not one big cave. This dotted line is the road that was cut through, and the road cut through 1, 2, 3, 4 cave systems. So that's looking northward on that side. And from 1964 on, possibly we have one of these, possibly Homo ergaster, possibly Homo habilis erectus. These may have been what we call Australopithecines. We can't say for sure, but very likely. But then in some of the caves, for sure, we have Homo heidelbergensis or Homo antecessor. These are often said to be variants of the same. but this is the more common term. And then, of course, we have Homo neanderthals and Homo sapiens. So this now means fairly recent. And to get Homo sapiens has to be after 50 KYA. Homo sapiens didn't really arrive in Spain until after 40,000 BP. So we could even push this a little further here. But this is possibly also modern intrusion into some of those cave systems. It doesn't have to be ancient humans that we call Homo sapiens. Now, looking at the depth of some of these caves, do you see how deep you have to go archaeologically into some of these zones? Karstic strata, karstic limestone is very soluble to rainwater. So when the aquifers bring the water down, the limestone dissolves and it opens up and creates karstic caves. And so some of these are karstic caves that these people were living in. This is called the Grand Dolina, or the Great Structured Cave. And you can see different levels as you go down. And you can see some of these galleries. Can you see how the limestone dissolved? See, there's the limestone here, and it dissolved. And underneath it, you say these layers. This is human activity, these layers underneath in the cave, for the most part, human. Now, here's a tool from that place. That's possibly either the earliest Homo heidelbergensis, which seems too early to be Homo heidelbergensis, or maybe Homo antecessor, possibly even Homo ergaster. But look at that tool. Now, you know Oldowan from the Olduvai Gorge in Tanzania, made famous by the Leakeys. That's a stone tool. Now, how do you know that's a stone tool and it wasn't just made by nature? That's a good question to ask always. Some of these tools are ambiguous. You could hypothetically get nature, breaking rocks. But when you have rocks with bifaces or more breaks in them, it doesn't seem to be natural. It seems to be a hominid created tool. And that's why we call this one a tool, not natural. And it means somebody struck that quartzite cobble that was water rounded. They struck it multiple times to create that. And it doesn't seem feasible that nature could do that. But, if you want to argue that, I'm open to argument on some of these. Now, this is the cave person who's been nicknamed in a sort of, affectionate way, Miguel or Miguelon. So this is one of the skulls that came out of that cave, the Cima de los Huesos. And you can see that the brain pan, the cranium, is smaller than you would like. It doesn't suggest a whole lot of sentience there with those massive orbitals for the eyes and that. But the teeth tell us a lot about the diet and so on. And so this is definitely a hominid, and it's almost 500,000 years ago and came from that cave system. Now, we could talk a lot about physiognomy, but let's not go too much there yet. And here's the reconstruction of possibly what that person looked like. Yes, just artistic reconstruction. Now, do you see the lower picture on the left that shows 4 individuals eventually arriving at something like us? And where the spinal foramen is, where the spinal cord is on your head, I guarantee it, is at the base of your skull, because you are bipedal, you are upright. But if you go back more than 500,000 years ago, that axis, that vertical axis where the spinal cord drops down from your skull, if you go back further and further back, when we are quadrupeds, when life is quadruped only, like your dog or your cat, you're walking horizontal, and so your head is this way, but the spinal foramen is the back of your skull, not the bottom. Does that make sense? So as we become more and more bipedal, our foramen for our spine becomes vertical, directly below the base of our skulls. So this has sometimes been a problem because when we've looked at some skeleta There could be debilitating effects of uh, uh, vitamin D deficiency, rickets, or other kind of spinal issues that could create a little bit of a problem to make sense out of that. Now, here are some of the tools that come out of that one cave. And you can just see, you know, some of these, I will admit, you know, it's not always easy to prove, but when you've got all these stones gathered together in a cave, in that kind of context, they're not lying around in nature. You see, an artifact, archaeologically, is anything that humans have modified. So I could go out into my backyard, and there could be a stone in my backyard that nature left there, and I could move it 2 inches, therefore modifying it. Then it would be an artifact because I moved it. But these stones are almost certainly artifacts, even though nature may have put them in place, people or hominids moved them. And after they moved them, when they become collected in a spot where they couldn't have been by themselves, that's a modified environment. That's now an artifact. Am I still making sense? All right. So when you get all these things together, even though it may not be obvious that they've been broken by people, the fact that there's so many of them together that nature couldn't have deposited in there. And when you then find marks on them, you may not see them, but there's microwear visible by a microscope when you can see scratches on these stones. And then you can analyze what scratched them. And there's contact with bone, there's bone tissue, microscopic bone powder on them, sometimes other things. Now, they're not going to have blood that lasts that long, but you can have bone powder on these, which again emphasizes that they're artifactual, that somebody was pounding something else with them. Now, this tool that I'm going to pass around again, this is like a Swiss Army knife from 500,000 years ago because it has multiple functions. It has one rounded edge that you can pound with and scrape with and pulverize things. It has another cutting edge along here or here, and it has a penetrating edge here. So it has 3 immediate separate purposes, and it fits perfectly in my hand. When I hold it, when I hold this tool like this in my hand, wow, does that feel comfortable? And it's something that somebody has been doing. There was a big gap, about a 500,000 year gap, when this stone tool was used and when it came into my study analysis. But it feels good in the hand, okay? I think we'll pass it around. And so by virtue of being the front row, you get to it first. I could throw it, but I think I better just pass it, okay? And yeah, so put it in your hand and see how it fits. Now, I have big hands. Now make sure the point is still sticking out at the bottom. Okay, I'd hold it a little more sideways than that. And is the flatter side against your palm or is the rounded side against your palm? Put the flatter side against your palm and you'll find it's even better. Is that better now? Yeah, okay, good. We have some lines of evidence building here. All right, so please, play with it, but don't let it distract you too much. All right, now, my PhD was on stone. And, people who know me and love me know that I've got rocks in my head. But this was part of my PhD work on stones. And I won't go into all the detail, but that piece that's handed around is flint, which is pretty pure silica, SiO2. Quartzite is not as pure. The windows that you see in this room are pretty pure silica. And because they're pretty pure silica, they're translucent. But if they had other things in them besides pure SiO2, silicon and oxygen, they would become more and more diffused. They'd become more opaque. So aluminosilicate rock, you can't see through it. It's opaque. So it can have iron, it can have calcium, it can have potassium, but the main equation for aluminosilicate is right up here, Al2SiO5. So pure SiO2, quartz by itself, quartz is only 98%. The other 2% are these other things. Iron, calcium, potassium, and aluminum. So anyway, my PhD was scientific. It was in archaeological science, forensics, and the sourcing, the aging, and how things were made of selected stones. So I did a lot on mineral leaching and on mobilization. So do you see here, there's a crust? Can you see that the inside is a different color than the outside? Because minerals over time leach out in the presence of water or other agencies. So anyway, now let's go back to Spain. So now let's go to this cave right here. We looked at the Atapuerca with Homo heidelbergensis, possibly something earlier, possibly older one, possibly Homo ergaster, possibly Australopithecine, but for sure Homo heidelbergensis, and all the way through to Neanderthal, but we'll get to Neanderthal later. Let's go down here to this cave. Now, Cueva Negra immediately tells you what in Spanish? What do you think that black is? Here's where that is, Cueva Negra Valley. It's a beautiful river valley. And you see these palisades on the sides? Well, those palisades, if you look deep into these palisades, you have cave shelters. And because they're open much to the air still, because they were not glaciated, scraped away, even though rock talus can fall down and cover the cave entrances with alluvium, this cave was pretty open. Now, look at this. You tell me, let's put our logic caps on, you tell me what that shows you immediately. Garage. Fire. Absolutely fire. That's soot. Now, could nature have done that? Could a fire have raged across that valley? And could brush inside that cave have burned? Yeah, hypothetically. But it's so deep in the cave. You're just seeing the cave entrance. This cave is pretty deep. And way back in here, you have high volumes of soot. Plus, you have a lot of charcoal on the ground and in piles gathered together. And what can we do with that charcoal? Radiocarbon dating. I worked as a graduate student at the U.S. Geological Survey Radiocarbon Lab, had an internship there, and worked with Dr. Stephen Robinson and the other physicists working on understanding radiocarbon dating. And if you have pure carbon, it's really good. So that's what you can use, radiocarbon dating, for that material. That's how we can get precise dates. Radiocarbon's half-life is 5,720 years. That's good, but it's probably not the best tool to use for something 500,000 years old. Maybe better to use something like strontium rubidium isotope dating, or even uranium thorium disequilibrium series dating, or possibly some other dating systems. But here's inside the cave, and here's some of the tools, like the axe that's being handed around somewhat. There are some of the tools in there, and plus some teeth. And teeth are great. What do teeth tell you? Diet. In the plaque in your teeth, any dentists here? Oh, we have a dentist. A dentist could assure us, as my dentist does sadly too often, that I've got plaque. Well, plaque can fossilize. And if it calcifies into the teeth, we can extract by analytical techniques, we can extract what the diet was from the chemistry in the plaque. And we'll get there today. Now let's move away from that cave, where it shows us what? That 500,000 years ago, humans could control fire. Easily, 500,000 years ago, humans could direct and control fire and localize fire. So we were already making great strides. When I say humans, I say broadly speaking. Hominids were using fire 500,000 years ago. Let's go to another cave. Let's go down to the bottom, Cueva Angel. And this is in the Cordoba Archaeology Museum, showing different sites. I'm not going to go there so much, but do you see this one, Cueva del Angel? That's this cave here. And look at the karst again. dissolved limestone. Here's the cave sequence. A lot of things in there in that cave. And if we look at this, can you see that the karstic limestone, it's melting, the calcite dissolves, and it redeposits on the cave walls. And when it redeposits on the walls, you can see that if there are things hidden in the walls or it recalcifies over objects found, we can also date the calcification. Calcification dating is a very important tool. Because when calcium dissolves and recalcifies, we can get a pretty exact date when that happened. And here's some of the tools, again, coming out of that cave, okay? This was Homo heidelbergensis to Homo neanderthalensis. So about 400,000 years ago to about 100,000 years ago. Now, this is just stone technology evolution. When the first hominids start breaking stones and breaking them more and more and more blows and more blows and more blows until this obviously is not made by nature. The stone being handed around, that stone that you're holding, or you will hold, I hope, that stone needed probably 20 to 50 blows to shape it. To create the sharp point on it, that's deliberate, purposeful breaking of a stone to make it more and more useful. And it eventually obtains a kind of symmetry. And the symmetry is there for a purpose. Symmetry in nature does all kinds of things, but symmetry, when we create symmetry, it's purpose-driven, it's deliberate human activity, and we're creating symmetrical tools. And eventually, we don't just hold tools, what do we do with them? We throw them, and we put them on the ends of sticks. And eventually, we put feathers on the end and we shoot them. And the more symmetrical they are, the less friction from air. So a stone tool that's flying through the air needs to be thin and long and narrow. It has to be shaped, and it has what we call, in scientific terms, reduced drag. So we eventually get there with these tools. Now, that's a picture I took in a museum in France, the National Archaeology Museum. You could see that guy walking up and down the street today. You know, he may not, he may not win a beauty prize, but we won't necessarily either, right? Does that look fairly normal to you? That's a Neanderthal face reconstructed, a Neanderthal skull. So this is the Mettmann Archaeology Museum, the Neanderthal Museum in Germany. National Geographic sent me there. This is one of the Spanish Neanderthals that's been reconstructed there from Gibraltar. There's another one from Gibraltar, from Spain, because that's where the Neanderthals were last seen. When I say seen, I'm sure our human ancestors saw Neanderthals. I'm positive. In fact, I have suggested in print and publications that the last Neanderthals in the world give rise to folklore like trolls, cave dwellers like trolls. Okay, anyway, that's a whole nother story. But there are some of these Neanderthals from Spain, and there I am holding a bracket fungus. That's a Ganoderm from the museum. Neanderthals ate bracket fungus, and it wasn't for food value. I'll get back to that. Neanderthals ate a lot of things that weren't just for food value. They were also medicinal value. Okay, so anyway, there's the one from Spain. Now, let's go to some of these. Let's go to this rock shelter, Roca dels Bous, it's at the foothills of the Pyrenees. Here you have it, the beginning of the Pyrenees, right up here. And here's this rock shelter that we call Roca del Bous. And there it is. You can't see it, but you see it right here where I'm pointing my pointer. You see that rock shelter at the base of a cliff. And now, of course, you've got a modern road to it, so tourists can visit it. You see parts of it? It has different sections. Has that section there on the right, and has another section interior between the two palisades. And when you look there, it had a wonderful view of the river, and it was probably also tracking animals along the river coming to drink water, etc. And here are just some of the things in it. A colleague of mine from the Institute of Archaeology in London, where I did my PhD, did a lot of this analysis and a lot of tools. Now the scale here, right there, can you see that scale? Those are centimeters. So essentially, tools like not too far different from what you're passing around. Now, let's go all the way down to the Guadalquivir River near Cordova. And here is that famous Iberian pyrite belt of mountains. Have you been to Cordova? Seen the great mosque cathedral there and other things? Well, here's this site called Silo Val Chillon, and there's one of those quartzite bifaces from there. So literally, you could say, in this particular case, you could say, a couple 100,000 years old. Now, we're going to take a break soon, but I just want to show you more of these flint bifaces. Can you see they're symmetrical? Nature didn't shape these. These were shaped by what we can call us in sort of large terms, hominids, okay? And here's another one. That's really a beautiful tool. Can you see it's held in the hand? Not tied probably to a shaft, held in the hand. Look at that sharp point. So that may not have as many Swiss Army knife multiple purposes, but you can see that it's got a very pointy penetrating edge at the top and very sharp cutting sides on the right. And you can do all kinds of things. You can scrape with these side edges. If you hold that stone that's being passed around sideways, you can use it to scrape skin. You can flence with it. You can cut out flesh from skin. You can do all kinds of, and you can take those skins and you can wear them. You don't want to wear them with all the gobs of fat and tissue in them, do you? No. You want to scrape it as clean as possible with a sharp edge like this. Now here, again, more Neanderthal skeletal remains, 120,000 to 25,000. Let's go to some more of these caves. Let's go way up here. There's a big cave system in the Cantabrian Mountains, which, by the way, get about a mile high. And look at this cave system. This cave system, what you see in yellow, there's 6 different caves. Some of them are Neanderthal and some are Homo sapiens. And if we go to this one, Pasiega, we find something fascinating. The Neanderthals had art. They painted on caves. Now, they may not be terribly representational, but they had all kinds of ways to abstract. Those are Neanderthal red ochre cave paintings, and they cannot be Homo sapiens. They're too early, almost 70,000 years ago. Humans, Homo sapiens, didn't arrive in Iberia in Spain, as far as we know, we may have to change this, but till about 40,000 years ago. So this is pre-Homo sapiens. And we can date these easily by when the limestone dissolves, it puts a veneer. Do you see that glossiness right there? The recalcification over the stone, which we can date, plus radiocarbon inside the cave. So look at that. What do we have? That's been defined, the middle thing has been defined as a scaliform structure, like a ladder. Do you see it? It's almost at 90-degree angles. Does that look pretty deliberate to you? That's not just somebody. Maybe we have an animal to the left above it. Hard to say. Maybe we have a human to the right. You see it? This might be an animal up here on the up on the left. Might be an animal there. That might be some kind of human there. Do you see it? Head, body, legs. Hard to say. But this isn't the only Neanderthal art we have, by the way. Now, when did we begin to speak? Okay, my wife and I, have lots of quid pro quos, a lot of transactional interaction where, she wants something that I don't want, or I want something she doesn't want, and we have to come together and compromise, usually, or I can get my way now, but she can get her way then, or whatever. But Neanderthals had what's called the FOX2 gene. They could speak. They had vocal cords. They could literally speak, guaranteed. Okay. We now know this for sure. Now, the Greek word for a cave dweller, troglos is cave, troglodyte is a cave dweller. And maybe that word troglodyte is even the international phonetic, what we can call the Proto-Indo-European root word for troll. But that's a whole other publication. I'm not going to go, I've written about this elsewhere. Now, let's look at the Neanderthals a little more closely. Have you seen these new articles about Neanderthals? The other humans, Neanderthals revealed? We now can identify some of the phenotypes of Neanderthals. Red hair is one of them, by the way. Okay, freckles is another. Okay, don't worry. Neanderthals had bigger brains than we did. Neanderthal brain pans are 30 cubic centimeters larger than Homo sapiens. And they had a lot of abilities. There's a new cave found in just south of Toulouse, a quarter-mile deep below the ground, with a lot of ochre and black carbon on the walls where they brought torches down, deep under Toulouse. And they broke off stalactites and stalagmites and they arranged them in circles. And they buried their dead. They didn't leave them for the other animals. Neanderthals had a lot of behavior that you and I would agree with. They buried their dead. They had art. They had language. They made things. They taught us everything we knew about stone tools. All their stone tool industry, Mousterian, they passed on to us directly. It had to be one-on-one teaching. They could communicate. They had a lot of what we call the same identical behavior. Now, that picture on the right is not the picture we use today for Neanderthals. Okay, we know there's shared DNA between Homo sapiens sapiens and Homo sapiens neanderthalensis. But that's a bad picture. That's a picture that we derogated them and we put them down. We said, "Oh, you're such a Neanderthal," right? We don't say that now and mean it in a bad way because we should be maybe praising them. That's a better picture of what we think they looked like on the right. Pretty much us. Okay. I don't have a TV at home. I've never had a TV, but I'll go to somebody else's house and I'll see these advertisements with Neanderthals and they look more like that. But you know, this is the better picture. Now, I see a lot of primate behavior. Okay. Okay. You know, the chest beating. The guy on the bottom right has pretty high Neanderthal. I knew him very well, David DeCastro. He was a Stanford lineman who happened to be an engineer, by the way. No dummy. Anyway, now there's the hand. That's your hand, maybe, or was. Pretty versatile. We're called Homo faber, humans who make things because of the complexity of our hands. Okay? Now, we have 20, maybe 26 to 27 bones in our hand, 7 bones in the wrist alone. Were you able to play with it? Everybody got it? Yeah? What do you think? You've touched history deeply now, you see, and now we've left all of our DNA on it, so there's no way we can work anything out. But it works, doesn't it? It's a Swiss Army knife 500,000 years ago. Pounding, okay, cutting, scraping, penetrating. You know, the tip has been broken off, but you see the weathering rind on it? See the darker outer surface? And that degree of change, coloration from minerals leaching out and redepositing, I can date that as well on flint. That was part of my PhD, to be able to date stone weathering. So anyway, look at your hand. Take a look at your hand. Now, I've got a broken wrist right now. I broke it on the Kleiner Matterhorn at 13,000 feet on a glacier recently. So I don't have the supination that I should. And I've got 2 titanium rods in this one. I've got titanium all over my body, shoulder, arms, legs, ankles, head. But I don't have the full degree of supination. But take your hand and move it around. And look at how important your thumb is. You are a tool maker. You use your hands like no other primate can do. Before we take our break, let's just look at the hands. There's a chimpanzee hand. Now it's versatile. can hold branches, it can swing, all kinds of things, but it doesn't have your thumb. That's a chimpanzee hand. Look at your thumb relative to that. Really long phalanges on a chimpanzee hand. You see it? Very long phalanges, but the thumb is deficient. It cannot grasp like you can, okay? Look at the hands. There's a baboon hand, a orangutan hand, a chimpanzee hand. Look at you have a really long thumb relative to the rest of your hand, don't you? Now, the reason we can move our hands so well is because we have those 7 wrist bones that aren't connected. They're only connected by tissue, by connective tissue, by ligaments and tendons. And that's why when I broke mine, I also tore half the tendons. So my hand is slowly healing, but it's tough to do things with it right now. And because I've got titanium rod right up to there, that one's a little, funky too. But look at your hand. And what can you do with your hands? You can make tools. And of course, you have a difference. Look at the length of arms. You can't swing from a tree like a pungid can. Look at those arms on a gorilla. But it doesn't have, look at the long digits, but it doesn't have long thumbs. Your thumb is probably part of the clue to why we made tools the way we do over time. And it's so versatile, the human hand. What can it do? Well, you can play Bach or Mozart or Liszt or Rachmaninoff. Okay. 3 of my teachers are on that list right there. Okay. Liszt and Rachmaninoff and Bach in my pedigree. Well, can a cat do that? Not really. So your hand is so incredible. Pitchers can do so many crazy things with a baseball because of those hands. Very sophisticated activity that we can do with our hands. You should be impressed with your hand, even if it's arthritic. Okay? Now, there is the most beautiful Neanderthal I know, my wife. That was taken in Greece, and she has 5% Neanderthal DNA. And she also has heavy bones, thick skin, red hair, freckles, a larger cranial pan, bigger brain than me for sure, and she can easily tolerate cold that I can't. She walks around in barefoot when it's freezing. My wife has 5% Neanderthal DNA. Interesting. And she's a lot smarter than I am. Guaranteed. Those of you who know her, Barbara, know that's true. All right. So my wife, 5%. We had to mate at least 300 times the Neanderthals to get that DNA that we have today. Is that fascinating? But maybe they're not a separate species. Maybe it's a subspecies. The argument is open right now. All right. There she is. And of course, we're passing that Neanderthal on to our grandchildren. You see, it's a double recessive gene, red hair and freckles. So, that's not easy. I'm maybe 1.5% Neanderthal. My wife is 5. The only other person I know who has 5% DNA is like my wife, Ashkenazim Jewish. So that's the only other person who has 5% DNA. He also is a lot smarter than I am. All right. So let's take a break before we get to some really astonishing stuff. Okay. Take a break. Quick break. Yeah. Oh, yeah.
The Neanderthal DNA, since they lived like 50,000 years ago.
Peppermint tea. Good stuff. All right. Yeah. We're just going to have a quick comment here.
I was just mentioning that a Neanderthal hyoid bone was finally found, and this bone is very delicate and doesn't usually survive and is critical for speech. So that sort of put the icing on the cake that the Neanderthals at least had all the abilities we have to make a range of sounds. It doesn't prove that they had a complex language, it just proves it's possible.
Thank you. Thank you. And with that, they had pretty much the same points to articulate sounds in the voice box. They had a tongue so they could make a pico-dental, pico-alveolar sounds. They had a velar stop so they could close the throat to make Ks and Gs and things like that. They had the same things. They had the same range of sounds that we do. Maybe different, maybe others too. John, yeah. Yes. Yes. Yeah. So we could communicate with them, apparently. Maybe too much communication is not good. I don't know. But could you over communicate? Well, whatever. But for sure, the Neanderthals had pretty much what we have, possibly because larger brains on the back side of the head, maybe different olfactory and auditory ranges, maybe more sensitivity. But as we were saying, there's a wide range in humans too, and Homo sapiens. But we don't know. Most Neanderthal DNA we have is mitochondrial DNA from the female, but we don't have a lot of Y male Neanderthal DNA. And there are different theories. Just to give you one, is that maybe the offspring of Neanderthal men and human women was not fertile. Maybe it was only Neanderthal women and human men that was fertile. But one other theory is that we decimated them, that we wiped out the men and mated with the women. Genocide. Is that a human problem? You bet. So there are lots of possibilities, but let's go to look at one cave down near the harbor. If you've been to Cartagena, right outside the harbor where the Spanish mole was built in the 18th century for the Navy, there's a huge cave. So you can see it here on the map. It's an incredible cave. There it is. You can see the sort of nativity and this big artificial human mole. Do you see that built out? But here's the cave. There's a Neanderthal cave right there called the Cave of the Birds. Cueva de los Aviones. Here it is, you see. It's right essentially there. You see it? Right there. Now, there it is. And you can see the 18th century Spanish structure above it on the right. When you go in that cave, and it's been very well excavated, it's easy to get to. It's right on the shoreline. And a lot of fish bones and bird bones found in that cave that had been eaten. So they had a lot of, marine diet. Now, they had jewelry. You were asking, John, jewelry. The Neanderthals had jewelry. There are many of these little shells that have holes in them where they were strung together. Now, the necklace itself is deteriorated, but we have the holes. And where they were found, shows that they were used as decorative items. Pierced pendants, pierced shells, painted shells. Do you see some of the paint on those shells? They painted the shells as well. So they were decorating. Now, the most fascinating thing, I think, is Neanderthal teeth plaque shows their diet. There are many things we can now say about what they were eating. When teeth plaque fossilizes, meaning calcifies with whatever else is going on there, it's not just calcium, other things. In the tartar and the plaque in the teeth, when it's fossilized, you can use spectroscopy to analyze parts per billion of what's in that plaque. You can get a chemical signature of what they ate, things that are only found in certain things. So they were eating poplar bark, populus, the species of tree we call poplar. Do you know what poplar bark has in it? High amount of salicylic acid. What is salicylic acid? Bayer synthesized it to become aspirin. Willow bark and poplar bark has high degree of salicylic acid. They were eating poplar bark for pain. Not just that. These are some mushrooms they ate. These are not food value mushrooms, okay? The Schizophilus commune and the Copernopsis cineraria. They were eating mushrooms not for food value because these two mushrooms have very high medical benefits. Not that they knew what cancer was, but anti-carcinogenic, antimicrobial, and insecticidal. And you can read about this in Nature, the magazine Nature, as well as the International Journal of Medicinal Mushrooms. There is such a journal, by the way. I may be writing for it soon. But anyway, because I work a lot on bracket fungus, mostly from Utsi the Iceman. But anyway, now, Neanderthal plaque, poplar, no food value that we can speak of. Bark? What would you be eating bark? Because it has aspirin, what we can call salicylic acid in it. And this is the Spanish poplar, which was very prolific then as well. It wasn't an introduced tree, it was already indigenous. Now, it also, the microanalysis shows dietary sources, mostly vegetal in Spain, but fungi, and they also they were eating mold, what we call slime molds, Myxomycetes. Why would they be eating slime mold? Penicillin, antibacterial possibilities. These are articles in the medical journals now that you can read about that they were aware of what penicillin did. Penicillium, okay? Doesn't that sound way pre-Pasteur? Okay. But the Egyptians also knew about how some of the fungus spores on bread stopped wounds from going gangrenous. They were rubbing moldy bread on wounds. The Egyptians were. We have this in the Ebers and Smith papyrus. So why not go back earlier to understanding some microbials, right? Especially in pre-literate places where they didn't write things down. I speak a lot about this. I may be teaching a class again. I used to teach an elective class at the medical school at Stanford called Medicine in the Ancient World. I taught it here, by the way. It's amazing what we've forgotten or never wrote down. Now, let's go back. Let's go to this cave. This is an Neanderthal cave. Do you see it over here? Okay, and not too far from Extremadura, and that famous gastronomic paradise, Carceres. Here's the cave, 64,000 years ago, Neanderthal. Pretty much on the surface, as you can see it, because the glaciers didn't wipe these places out. And look at the hands. Those are Neanderthal hands stenciled on the walls. These are not Homo sapiens. These are Neanderthal hands, okay? 71 Neanderthal hand stencils. You're looking at sort of the artist's hand. Now, what do you see when you look at that hand? The hand on the right. That's not a reversed image. Which hand is that, left or right? So that means what? Artist was left-handed, or at least painting with the left hand. You have both. Now, I want to go to a cave that's just hybrid, down at the bottom, down in Andalusia, right on the coast, down here. Let's go to Zafaria Cave, because it's both Neanderthal and Homo sapiens. Now, I have to throw a whole wrench into the works, because when I was in Morocco a few months ago, actually not a few months ago, now it's 7 months ago, at the Rabat Archaeology Museum, they had an exhibit about what they posited was a hybridized skull. What they said was the oldest possible Homo sapiens, but was easily also hybridized with Neanderthal. And it's 315,000 years ago. 315,000 years ago, meaning that Neanderthals are in Morocco for sure. And that's possibly one of the ways Homo sapiens came across when it was still a land bridge, before the sill broke between the Mediterranean and the Atlantic. Whatever the case, if that's the oldest Homo sapiens we can think of, or hybridized Homo, that's a pretty big head. That's a pretty big cranium. It shows both Neanderthal and Homo sapiens characteristics. But we know there are caves like this one we're coming to, where at the Zafaria cave, as they were coming across the land bridge here, we know they were living together and mating, because we have in this cave up here, that's looking up the sort of saddle between the ridges. And here, if you go into the cave and look out, can you see one side? And inside that cave, we have hybrid mandibles and femurs. We have bones, dentation, bone structure that are both Neanderthal and Homo sapiens together. And in this cave we have, here's Ian Tattersall. He's a very, very good scientist, and he's showing we have hybrid places where Neanderthals and Homo sapiens mated and lived together. We have offspring that are hybrid, that are both. We have skeleta in Spain now that show both Neanderthal and Homo sapiens characteristics. And you can look up Ian Tattersall, you can read the Proceedings of the National Academy of Science. Anyway, this is another cave is in Portugal that shows hybridized. So that's 27,000 years ago. That was just before they were wiped out or disappeared. Several generations of coexisting Neanderthals and human beings together in the same cave at the same time and with offspring in the same cave. Several generations of offspring. So now let's go to Gorham's Cave, which is right on Gibraltar. And when we look there, you can see the Rock of Gibraltar. Okay, this big, massive rock sticking out. And Gorham's Cave is down here on this side. And remember, that was a land bridge between Africa and Europe at one point. Here's Gorham's Cave right on the edge of the water. And there it is looking at. The last Neanderthals in Spain lived here in this cave. Okay, 28,000 years ago. It's 25. And one more cave now. We're done with the Neanderthals. Let's move on to Homo sapiens. Here's a cave with Homo sapiens, very close right there. And here it is on the coast, at the town of Nerja. And when you go in, a lot of stalactites. Again, you can date stalactites. You can date the recrystallization of the calcium carbonate. And when it recalcifies below, sometimes over artifacts, again, you can date it. There's a Homo sapiens skeleton in the Nerja caves. That's us for sure. Okay. And look at, they painted seals in that cave on some of the stalactites and stalagmites. But this is right when Homo sapiens come into Spain, 40,000 years ago, right on the cusp. The other cave I showed you, the Dafra, that was later. That was 28,000. That was after this. So Homo sapiens are here. This cave is just Homo sapiens. But remember, this cave here, the Dafra, is both, but it's later. So the first Homo sapiens about 40,000 years ago. And now this is interesting. The oldest domesticated dog bones we have, the absolute oldest, is from Spain, northern Spain, Cantabria. And it's the oldest dog bone. I don't mean what the dog was chewing on, the part of the dog, okay? 17,000 years ago. That doesn't mean it didn't happen earlier. For sure, dogs were domesticated before 70,000 years ago. Possibly, we think now, it was 30,000 years ago that the dog was domesticated. From the wolf, Canis lupus to Canis lupus familiaris to Canis domesticus. Now, for 10 years in our house, we had a dog that we thought was a dog. She was terrible. She was a lawsuit. She was given to us by Dee Dee Silverstone. Alicia Silverstone's mom. They were some friends of friends who, our daughters decided to have their pictures taken with Alicia, but there was an obligation. They had to take a dog. This dog was totally unwanted. We were the fourth owners. The dog was about to go up in smoke, if you know what I mean. But because our family had agreed to be in this photo session with Alicia Silverstone, we took this dog. First night we had her, she bit every one of us. And she was not an easy dog. It turned out we thought we'd put her outside at night. First night, she's howling. And I went out to try to find out what she was howling about. Literally, oh, she cornered a skunk. Well, guess who got skunked? Not the dog, me. But anyway, this dog, she was very protective after about 3 weeks. But I had one of my students who lived in Alaska stop over at the house, and she said, Dr. Hunt, that's not a dog. That's a half wolf. Our dog was half wolf. Okay, it's very likely to have half wolves, right? When you have a choke chain on a dog and you take the dog to dog obedience school 4 times and she flunks every time because she's too aggressive. Anyway, this dog, she loved us. It was true, but she wasn't really a dog. She was half wolf and about as domesticated as a half wolf could be. What a handful she was. My wife had to get shoulder surgery from walking this dog, right? But anyway, Roald Dahl, not the nicest person in the world, had a very funny story about how wolves became dogs. Lurking around our fires, smelling our barbecues, they decided that our meat that we had for dinner tasted better than we did. Eventually, dogs became domesticated from wolves. And you see this all the time. If you read about it, you'll see that there are wolves mating with dogs. It's still Canis. Canis lupus is not really different than Canis domesticus. So we domesticated the wolf into a dog about 30,000 years ago. The oldest dog skeletal bone is from Spain. Totally makes sense. Now, domestication is a mixed bag. First cats do domesticate. Can you domesticate a cat? I'm not so sure. We can kill her either now or we can let her live and she'll feed us for the next 15 years. So domestication, whatever it is, but it's in Spain that we have that. Now let's go way back up to the north. Let's go way up near Santander and San Sebastian, another great gastronomic capital, San Sebastian. Let's go up here, just west of the Pyrenees, and here's Cueva de la Praileaits, 18,000 years ago. You can see a human head for scale there, a nice shiny head. Okay. And here are some of the Venus pendants, we think, from that cave. A lot of Magdalenian pendants from that cave. Look at, you see, they cut holes in things and carved them and shaped them. And, some of them are wild goat bones and some of them are just steatite or slate. But look at this, all these decorative things. And some of them had decorations on them as well. All kinds of decorations, feathers, rainbow, reindeer, beads, pendants. So let's go now to another great cave, Cave El Miron, not too far from there. You can see very close to Santander. There's the cave right in the side of the palisade, overlooking the water. And here's some what you call, what a scapula is in your back, right? It's pretty lightweight, wide bone. And these are spear throwers, not lateral throwers, where you hook and you throw with one of these pulsars. So these are spear throw, and they also had bone needle tips. Those are needle tips. Look at 2 millimeters, very, very tiny little needles they're making from bone in that cave. 19,000 years ago. And look at the carved reindeer. You see that here's a drawing of it, but there's the head. Do you see it? Carved red deer scapula. And if we continue here at Jarama, in the center of Spain, very close to Madrid, here is a small carnivore. What is it, a wolverine? We don't know. So that's literally, 20,000 years ago. And if we keep going at these final caves, finishing up, here's Cueva del Moro, very close to Gibraltar. Do you see Gorham's cave right there? Here's Cueva del Moro, Cave of the Moor. You can see it up on the hill up there, pretty high, but pretty protected. How would you get to it? Ropes, ladders? It's pretty defensible. And here's the view, looking down on the Mediterranean, or in this case, the Atlantic. And look at this. Here's a rhinoceros. You see it? There's a rhinoceros carved into that one. Here's a close-up of it. So technically, we can say that literally here, only 20,000 or so years ago, there were still rhinoceros running around. But remember, this is when the Ice Age is still raging across Europe, there's no Ice Age here. So we have this long continuous sequence. Now, as we finish up towards the rhinoceros, here are a lot of stone tools from Chalcopyronian to Aughnasian, roughly 35,000 to 17,000 years ago. Very small stone tools and bone tools. You can see awls. You see the bone awls? So last ones, here's one that I love. When I went to Menga, a Mesolithic, a megalithic site, look at that. Does that little hill look pretty, shall we say, spectacular? It really sticks out of the landscape. Had a lot of caves in it. It was a sighting line for a lot of things. There's the cave El Peñón de las Enamoradas, the cave, basically the Peñon of the Lovers. And here it is close up. And you go up on top and you can see from the plateau. There's another picture I took of it. Another picture I took of it. Look at that cave in the shelter. Upper Paleolithic to Neolithic. There's the cave. And look at this. What do you see in there? All these cave paintings. And these are pretty recent, 15,000 years ago to 9,000 years ago. Not really any better than the Neanderthal ones, technically. All right, finishing up. Let's go way back up to the north to the most famous one of all, Altamira. Here it is. You can see it right up here, Altamira. And, discovered by people looking for animals who'd broken into this cave. The owner, a local aristocrat in the Cantabrian Hills. And you can't see it's hidden in the trees here. The cave shelter right in that little sort of scarp. There it is now, closed off. You have to have a permit to get in there. But when the local animal tender found some of his animals had wandered into that cave, and he went to find them, he went with a torch and found all the paintings on the wall. And then he came back and told the Lord, who wrote it up, discovered it, and very famous man, Don Marcelino Saltaola, he made this possible. People didn't believe him at first. He thought that he painted these. But you look in the great gallery at Altamira, 51 ceiling cave animals from 36,000 years ago to 20,000 years ago, meaning right between two ice ages. But it was flourishing, but it wasn't touched by, even though you're close to the Pyrenees here, the ice age didn't seem to create glaciers down here. But there wouldn't have been any anyway, because this is an intermediate period, an interglacial period. Look at these cave aurochs. This is Bos primigenius. These were literally 6 foot high at the shoulders. The head's another 2 feet above it. This is the ancestor to cattle. We know Egypt had a pen of these over 10,000 years ago, and they started downsizing them, mating the smaller with the smaller to get eventually cattle they could handle. We can see by looking at the horns that auroch paintings appear in Old Kingdom Egyptian images. John, yeah. Pretty high. You'd have to get up on the ladder. Some of these are 10 feet high, some higher, 15 feet high. Oh, they would have to have ladders or piles of dirt. They could modify. Look at these beautiful animals. And essentially, remember, these are, you can see, roughly speaking, 30,000 years ago. Beautiful, aren't they? And here's some auroch horns from the museum. Those are 7 feet wide, greater than 2 meters wide. So this is how wide those horns are. I have a 7-foot wingspan. Okay, you see that? That's how wide those horns are. Get out of the way. It took quite a few humans to get down on them. There are some, look at the incision of that stag. You see that? That's quite a rack. Here's another auroch, Boas primigenius. Now they could blow red ochre against the wall. These are bone tubes that they could attach. They carved a little flange, like a mortise tenon to connect them. They would blow the ochre against the wall, then paint. When they blew the patch of red ochre on the wall or the ceiling, then they could delineate it with other colors, you see, like that. You see the black charcoal? Red ochre with black charcoal. Look at that beautiful horse. That's a horse before horses died out in Europe and Spain, and then had to be reintroduced from the Caucasus and the Black Sea about 4,000 years ago. So the horse died out in Europe. Look at that. There's a red ochre doe. Let's do a close-up. Look at the face. And then this is from the Cambridge Encyclopedia of Archaeology, from 2 bison mating there in the cave. That's just a sketch. Here's some jewelry, Neolithic jewelry, restrung beads. I don't think the Neanderthals had much different, according to what we've discovered from the Cave of the Birds, Avionis and others. Here's some Neolithic tools, smaller tools. You can just see them, they're rounded. Not really different than our local Ohlone charm stones, by the way, which I have excavated quite a bit of. Now let's just finish up. So let's go back to El Castillo to finish up. Remember, La Pasiega is Neanderthal, but this one is Homo sapiens, this one right here. So that one is Neanderthal. That one is Homo sapiens. Oh, you can see by the scale of the trees, hundreds of meters apart. Yeah, you see the river runs around that valley. You can see the forest. So they're not very far apart. In other words, they might have even known about each other's caves, but the La Pasiega is much earlier than humans, so Homo sapiens arriving there. This cave here, La Pasiega, is about 70,000 years before Homo sapiens arrives on the scene. So we couldn't have been there then. But now let's look in that cave. So here's El Castillo with all the contexts pointed out. Here's an incised deer on a scapula. You see the deer on there? And then here's what it looks like, you see. And by the way, what does this mean? All those lines? Movement. Remember, we have single fixed incandescent or LED lights. Their light was flickering in torchlight, which means it was cinematic. They could see things move with the light changing. Isn't that interesting? Now, finishing up. There is a beautiful bovid, there's a deer, a stag on a cow horn. There it is again. Look at these now. Now, here's a bison. And what do these dots mean? They were counting time. They had calendrical markings. Often when you have lines like 17 or whatever, 13, it's the days when there's no moon in the sky. They were counting time because when you're sourcing food, you're also very importantly trying to calculate the time. We now know the oldest moon sighting spot in the world is a Metholith site in Scotland 8,000 years ago, where they were watching the moon over each month. Why moon? Because the tides and the moon's phases, and Schleim, an anthropologist, said women invented time. Why? Counting the months, counting menses. Now, here are these food procurement leads to calendrical markings, leads to time measurements. So they're marking time in the caves. All right, we're neither hunters nor gatherers, we're accountants. Why not? All right, finishing up. More caves at the hands. Now, do you see some left hands there? Okay, 3 left hands, meaning whoever did this was either the 3 artists or 2 artists or 1 artist painting with the right hand. Look at that. All right, that's my last picture. What I want to point out, even though this is earlier, this is going back to Altamira. That is staggeringly insightful. You can almost read emotions and character in this incredible painted image from about 30,000 years ago. Is that not astonishingly astute? And remember, they're not painting dead animals. They're painting animals inside the cave that they saw outside the cave. They're not bringing dead animals in. That is a living animal. And the life, there's such sentience in this image that when we think of ourselves as artistic and resourceful, when we think of ourselves as Homo sapiens, remember, we have antecedents that weren't very different. So we've looked at Spain for over, we've looked at least 500,000 years of the Stone Ages in Spain. I trust that you're excited about what we're going to discover next. So thank you for your patience.
Professor Hunt, Dennis Bryden online
Any
has a
quick
question.
questions? I know time has run out, but any questions? Yes. Did they hunt these animals to eat? No doubt, but they also identified with them. Sometimes they're clan names, clan identifications. Sometimes they're deified as spirits. But yes, they did hunt them. Yes, question. Bison? Well, more or less what we call bison today isn't necessarily the exact same critter. Yeah, they're related. Yeah. The bison that you see here in this picture looks very similar, but it doesn't have to be the exact same species. Yeah, it's just a generic name. Good questions. Yes, sir. Yeah, yeah, yeah. Are there paintings of woolly mammoths in Spain? To my knowledge, not that I've seen. That doesn't mean they don't exist. But it's hard to know if the Elephantus groups were in Spain. Rhinoceros for sure, and if you have rhinoceros, you have common, habitats. So let's take a rain check on that one to see if they had elephant species in Spain. I can't answer that. From the evidence I have at this point, no. But wonderful question. Any questions from Zoom, from our Zoom participants? I'm not sure I can access them. But if you have them, please email me at phunt@stanford.edu. Thank you and hope to see you next week.
Professor? Professor? Okay.
Thank you, John. John, great to be back. Thanks for your great questions too.